Yeah, unmute it. I have to.
Can't hear anything. Have you unmuted yourself?
Yeah. Can you hear me?
Yeah.
Yeah. Right?
People online, can you hear us?
No, it's back.
It's look like.
Yeah. Okay.
Okay,
Yeah,
good.
that's fine.
Good to go.
Right. Thank you guys for joining the event. Yeah, today I'm gonna show you about the project I've recently done, video composting. First of all, I would like to introduce myself quickly. My name is Rihan Ligari. I have recently joined Team Creation, and currently I'm working on some very interesting video solution under the leadership of Black. So today I'm gonna show you one of the project I've recently worked on, and this is it's all about video compositing. Don't worry if you don't know about video composting. I will explain what it is and how we are using it on probably very occasionally, but we don't know that we are. So video compositing is basically a process of taking several video streams and joining them together in a single video. So there will be multiple input videos. For example, we have here 4 input videos, and after compositing, the output will be one video which will have combined all the 4 videos. So they are stitched together. So this is called video composting. So what are the applications for it? Like we use in real-time video conferencing, probably when we are doing Zoom call or something like that. We are using it and the other applications are like multi-camera surveillance. Like you can see, if you have probably used this thing, so you probably will be. So in this case, we are using video composting under the hood, and what it is, I will explain a bit more. So first of all, why we need the video compositing? There are several, like I mentioned, there is one good example is a video conferencing. So this is how under the hood we have like connected for example, we have 5 person who want to do the video conferencing. So we have different topologies, like how they will interact with each other. So in this second topology, which is called MCU, we are using video compositing. So all the people will be sending their video to the one central server, and the central server will act as a video compositor and mix all the videos and then send only one copy to each person back. So that's how you see everybody when you are doing a video conferencing. That's how you see all the videos together. So this is where in the second example we are using. So this is kind of important, because if we don't use video compositing, we will have to go back to the mesh and SFU topologies. But then you can see the difference. We have some numbers on the top, like we will be using more bandwidth and more connections, which is not so ideal. So that is the main reason, like it's efficient way of doing the video conferencing thing. The second thing is why we need video compositing in compressed domain. So the traditional compositing is like whenever we need to change the video, we have to first decode it, like getting an uncompressed video, like video pixels. Like this is where I'm try to explain what is video pixels are. So whenever you see something on the screen, these are made of small pixels, like and these are pixels made of RGB values, like combining the red, green, blue values, it make a 1 pixel. So this is how you see a video on the screen. So if we have to do the compositing in traditional way, it's very easy. You decode it, you have the pixels, and you can manipulate it as it is, as you want. Like you can adjust like all the videos together, like first pixel of the first person, then pixel for the second. So that's very easy. But it comes with the problems like it's a high computational cost because we have to decode the video first. Whatever the video we are receiving, we have to decode it, and then after the manipulation of the pixel, we have to re-encode it. So that is very in the video thing. Like it's very these operations are very expensive, like in terms of CPU usage, and also this cost increase in latency. So if one person video is coming over to you, it will take a bit of time because it has to decode and encode. So these kind of thing, which is the problem. So what we wanted to do is like the goal is like we wanted to do this without decoding and encoding. So this is our goal is. But I'll just quickly show you like how the video works. Like video data is quite huge. Whenever we have the video data, like a file or recording, whatever you're doing, so it is a huge data. So we always encode it to some format, like to compress it, like WinZip thing, like we compress it. And whenever we want to play it, we can't just play it back. We have to decode it before you can see that video. So this is the process, a very high level diagram, which shows like whenever we are recording, we are doing encoding. So we compress the data. And when we want to see the video file, we have to decode it. Like the output will be a raw pixel, which you see on the screen. So this is just a quick background. What is video encoding and decoding? So now coming back to requirement, what the requirement was. So like I mentioned, the traditional video compositing requires us to decode and encode, which is quite expensive thing. So we have to develop a real-time software-based solution where input was live encoded video streams, and we have to stitch them together and without decoding and encoding. Again, that's the main difference. So this is, I'll quickly show you two images. Like for example, what is traditional video compositing, like what most people use, like when we receive the video sources from different live streams, the composer, before we can stitch them together, composting is basically stitching the different videos together, we have to decode it. You can see here it has a decoder in it, and then it do the compositing, what is like stitching the videos together, and then we encode it before we have one single output that will be sent to every recipient of the video conferencing, so you can see everybody, right? So what we have achieved is video compositing in compressed domain, where we are not doing any decoding and encoding, and we have managed to successfully stitch all the videos together into one stream without encoding and decoding. So this is the very high level diagram, what's the traditional video compositing and what is in the compressed domain. So this is what the second one, what we have achieved. The second thing is like just a quick thing, what's the concept of this compressed video compositing in compressed domain is. Like we are directly, like I mentioned, we are directly working in a compressed domain. We are not doing any decoding and encoding, you can see. And the input of the system is a live video streams, and the output will be one stream. So that output stream will contain all the videos in a rectangular form or whatever is required. And the benefit of doing this is no decoding, encoding overhead. Low latency is basically a delay. So because we are doing in the live streaming, so there won't be any delay because we're not doing any processing. So video is going as fast as we are receiving it. So, and preserving the compression. So remember, whenever we in the video whenever we encode and decode, it's a lossy operation. Like you can't get the same quality back when you encode a video, and when you decode it back, so you won't get the same quality that it used to. It's a lossy compression. So in this case, because we're not doing any encoding and decoding, so we preserve the actual quality of the video. So this is probably not for everybody. This is like a bit for technical persons like who wanted to know like how it was achieved, because it's very important to know how it was achieved. If I can't miss that, but it's a bit of technical thing. Like we are combining. These are the two streams like on the top, and we are combining them. We have found basically a way to how to combine the NAL units of the multiple stream into one. So this is how it was achieved. This is not probably, it's a bit technical like inside how video works, and this is not for everybody, but yeah. So this is a very quick one. Like we have to combine the types of the frames in the encoded video to the match to the same one. This is another technique we have used to match the frames, iframe with the iframe, so that the composer is easy to merge the stream. And yeah, this is our achievement. Like we have a novel method for video composting of live H.264 stream, which very efficient in a way that it doesn't buffer, it reduces the latency in the system, and it preserves the quality and enabling us to build some next generation video platform. So yeah, that's all of it.
Thanks a lot to Rihan. So, like many of you, I do video calls every day, but never thought about the technology going behind what shows on my screen. So, thanks a lot for bringing that up. So, next up, we have a colleague from ED again, William from senior